Hello guys, welcome back to another problem solution video. Today we have yet another question here, and as always, let's first start off by reading the question. So, determine the number of the number of triples k, l, and m of positive integers such that k plus l plus m is going to be equal to 97, and 4k divided by 5 plus 5l divided by 6 plus 6m divided by 7 is going to be equal to 82. Now, this is from the COMC contest, 2003 version. It is the 8th and final question of part A. So, let's first start off by looking at this equation here. So 4k divided by 5 plus 5l divided by 6 plus 6m divided by 7 here. We can see here that this obviously means that k has to be divisible by 5, l has to be divisible by 6, and m has to be divisible by 7. This is because, well, 6 and 7 here don't share any common factors. 5 and 6 similarly also don't share any common factors, and so does 4 and 5. So this means that k, l, and m must have factors of 5, 6, and 7 respectively. So instead of k, l, and m, we're going to write 5a, 6b, and 7c. So 5a plus 6b plus 7c is going to be equal to 97. So we'll label this as our first equation. Now we're going to rewrite this by plugging in the fact that k is going to be equal to 5a, l is going to be equal to 6b, and m is going to be equal to 7c. So we're going to plug that into here, and then we get 4a plus 5b plus 6c is going to be equal to 82. And we'll label this as equation number 2. So now equation number 1 minus equation number 2. This is going to be equal to a plus b plus c. It's going to be equal to 15. Okay, and now we're going to label this as equation number 3. Now equation number 3 multiplied by 6 minus equation number 2. We can see that this is going to be equal to 2a plus b. This is going to be equal to 8. And we'll label this as equation number 4. So now if you subtract equation number 3 from equation number 4, so equation number 3 minus equation number 4, right? This is going to be equal to c minus a equals 7. And from here, I'm going to draw out a little bit of a chart. So alright, so we're just going to label a as if a is going to be equal to 1, 2, 3, and 4, keeping in mind that c minus a is going to be equal to 7, and 2a plus b is going to be equal to 8, and a plus b plus c is going to be equal to 15. So these three. We can see that if a is going to be equal to 1, c here has to be equal to 8, and b is going to have to be equal to 6. Why is this? Well, because c minus a is equal to 7, and as we're saying, let's just say a is going to be equal to 1, b would have to be equal to 8, and since a plus b plus c is equal to 15, or you can use 2a plus b equals 8, b has to be equal to 6. Similarly, we just do this for all of these. Now you'll see why I stop at a equals 4. So this would be 9, 10, 11, 4, 2, and 0. And if you go farther past this, so let's say a equals 5 and c is going to be equal to 12, well then b will have to be a negative number, and it will no longer be a positive integer. This is why we also can't use 4 here, right? So these three, so if a equals to 1, so these triplets, 1, 6, 8, 2, 4, 9, 3, 2, and 10, these are fine, but once you go past 3 and start getting to 4, 5, 6, 7, and beyond for a, we can see here that b will start to become negative, and we can't have, will start to be negative or b equal to 0, as you can see here, and we can't have that as we need all of them to be positive integers. This means that k, l, m, so we're going to plug in the fact that k is going to be equal to 5a, l is going to be equal to 6b, and m is going to be equal to 7c, as I said before. We get these three triplets. 5, 36, and 56, 10, 24, 63, and 15, 12, and 70. So these are our three triplets, and that's the answer to this question. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.